students. Welcome to another program for Elimu Live on KUTV. Today we are having our lesson in mathematics for Form 4. We are looking at mathematics for Form 4. The topic we are looking at is integration. Integration is one of the topics on calculus that we teach in high school, which we want to summarize in our today's lesson. Before we look at the main things in the topic as outlined on our board, we are going to do the integration of polynomials. We are going to look at the definite and indefinite integrals. We are going to look at area under a curve. And then finally, it's important to know that we shall also have to look at application of integration to kinematics. Welcome to our lesson. I'm your teacher, Mr. Ndenga-Global. Now, before we look at what we have in integration, it is important to understand what integration has to do with. And when looking at integration as a topic, we are looking at the reverse process of differentiation. So that is the meaning of integration, the reverse of differentiation. So we need to start by looking at what is it that is done in differentiation that we end up looking at integration as the reverse process of integration. So in this case, for a function y is equals to ax power n, when you're carrying out differentiation, what we do is we start by subtracting 1 from the power. So we have dy and dx representing the derivative becomes, we take a, we multiply by the power, then we have x power n minus 1. This is the process for differentiation. And in this case, what we obtain here is what we call the gradient function. We obtain what is called the gradient function. So when you have a function of a curve, now differentiating or carrying out a process to obtain the gradient function, that is what we term as differentiation. And so in integration then, if it is the reverse of differentiation, then it means we are going to be given the gradient function now to obtain the function of the curve. And so the process by which we obtain the function of the curve from the gradient function, from the gradient functions, is what we call integration. The process through which we obtain the function of the curve from the gradient functions, or simply the derivative dy dx, is what we call integration. So in this process, we are going to do the reverse process of what we've done in differentiation. So if we have dy dx, which is the gradient function given as x power n. So the first process in differentiation is to multiply the power and the coefficient. Now in this case, this process becomes the last process in integration. And so what we do first is the last stage here, where we subtract 1. Now we did the opposite of subtraction, is we add 1. So it becomes x power n, we add 1. And then the first process, which was multiplication, now the opposite of it becomes division, but we divide by the new power, n plus 1. And then we add a constant c. So this is how we carry out integration. We add 1 to the power, divide by the new power, then we add a constant c. For the case of functions, for a case of the function y is equals to, that's dy dx is equals to 2x squared, what we are meaning is we add 1 to the power, so we have 2x, 2 plus 1, then divide by the new power, which is 2x plus 1, and then add the constant c. And so this becomes now the function y is equals to 2x power 2 plus 1 over 2 plus 1. So this gives us 2x cubed over 3 plus c as the equation of the curve. Again, we need to remember the process of integration. The process of integration is represented or written by a symbol. The symbol for integration is this sign. So we have x dx. This simply means integrate with respect to x. And so if we have any function, like if you find this case, if you're told to evaluate x cubed, this simply means integrate. This symbol here implies integration. It's a symbol to imply integration. So in most cases, we are not going to say integrate, but rather we'll simply say evaluate. Then we write this sign with what you want you to integrate at that point with respect to the terms that you are working with, that is dx. So that is what we need to understand before we look at the details of integration, that we integrate by adding 1 to the power, we divide by the new power, and then we add a constant c. And in some of the cases we are going to work out, we are going to determine the value of c and then put it into the right perspective in terms of the equations of the lines. So let's look at a comparison between this case and the differentiation. Now, if we have what we call the gradient function, we can have here our gradient function. And we're talking about the gradient function, that is our dy dx, which is captured in differentiation. And then we have here the function of the curve. So it is the function y. If we have now the derivative, the gradient function given as x cubed, that is the dy dx. Then to obtain the function, this is the process now integration. To integrate in this case, we are saying we add 1 to the power, so we have x power 4. We divide by the new power, which is 4, and then we add a constant c. That is the derivative of x cubed, the integral of x cubed. It's x power 4 over 4 plus c. If you have now 2x squared plus 3x as our gradient function, then the integral value of this will be 2x. We add 1 to the power, which is now 2 plus 1, that is 3. We divide by 3 plus 3x. At this point, x is power 1. So when you add 1, it becomes x squared over 2, then plus a constant c. If you have another one, we have a quarter x cubed minus 4 as our dy dx. Again, add 1 to the power, so we'll have 1 over 4 x power 4. We divide by the new power, which is 4, then we minus 4. Now at this point, x is power 0, and so x now becomes power 1, then plus a constant c. So if we work out a quarter, this is 1 over 4 and 1 over 4, we shall have 1 over 16. 1 over 16 minus 4x plus c. So this is how we carry out integration when you're given the gradient function, which is the value for dy dx. And so let's look at further, how do you work out a case where you are supposed to determine now the equation of the curve? Because in differentiation, what we were dealing with were to determine the gradient of the curve. So you are told, for example, you are given a question That is in differentiation. In differentiation, you are given a question, you are told that you determine the gradient of the curve, of a curve y is equals to 2x squared plus 3x minus 5 at the point 1, 5. In differentiation, this is the case. We are looking at the gradient of the curve. So what do we do in this particular case for differentiation? Because we are determining the gradient of the curve at a point, then the first thing that we need to do is to obtain the derivative, which is the gradient function. So our solution will be gradient function, which is the dy dx, is we differentiate. So let's differentiate together. 2, we multiply by 2 to have 4x. Then we minus 1 from the power, so we are left with 1. Then plus, at this point x is power 1. So 1 by 3, that is 3. Then 1 less 1, that gives us 0. And then anytime you differentiate constants, it gives you 0. So this is our gradient function. And so at the point 1, 5, x is equals to 1. So we replace it here to have 4 into 1 plus 3. So it gives us the answer is 7. So our gradient in this case is 7. When it comes to now integration, we are not going to obtain the gradient for the curve, but we are going to obtain the equation of the curve. So if you work out this case, you are told now in integration now this will be the case for the same case. You are told the gradient function of the curve of a curve, gradient function of the curve or of a curve is equals to, a curve is 2x squared plus 3x minus 5. They are told to determine the equation of the curve. The equation of the curve at the point 1, 5. At the point 1, 5. So in this case now, what we do is, again, we look at what we've been given is the gradient function, which is this case we are showing in our table. The gradient function is 2x squared plus 3x minus 5. So to obtain the function, as we've already shown here, we have to integrate this gradient function. So when we integrate now, we'll say our y becomes, we integrate 2x squared plus 3x minus 5. Let's integrate. We are saying integration now we add 1. So we add 1 to this. We have 2x cubed over 3 plus, at this point we have 1. So we have now 3x squared over 2 minus 5x, then plus a constant c. So this becomes our function for y. And if this curve is passing through this point, then it means at the point 1, 5, it implies that x is equals to 1 and y is equals to 5. So we will use these values to replace in this equation so that we obtain the value for c. So if x is 1 and y is 5, substitute it here, we'll have 5 is equals to, now we have 2, 1 cubed over 3 plus 3 into 1 squared over 2 minus 5 into 1 plus c. If we work at this we shall have 5. This is 5 is equals to, this is 2 over 3 minus 3 over 2, then minus this plus minus 5, then plus c. This is over 1, so our LCM in this case will be 6. And so we have 5 is equals to, that is 4 plus 9, then minus 5 over 6 plus c. So that should give it 13 minus 5. 13 minus 5, that is 8 over 6 plus c is equals to 5. Then we take this to the right hand side. Our c becomes 5 minus 2. If you simplify, this is 4 over 3. So our value for the constant, that is 3. 15 minus 4, 11 over 3. So it means, therefore, the value for c in this case is 11 over 3, which is 3 and 2 over 3. So therefore, what is the equation? The equation is supposed to be y is equals to 2x cubed over 3 plus 3x squared over 2 minus 5x plus c. So we simply write this, and instead of c, we write 3 and 2/3. So our equation becomes y is equals to 2x3 over 3 plus 3x squared over 2 minus 5x plus 3 and 2 over 3. That is the equation of the curve. So students, you should be able to note the difference between how you'll be asked in differentiation and how you'll be asked in integration, because they almost share some information, and that's why we are explaining integration as the reverse process of integration. And so number 2, after we've seen how to integrate polynomials, let's see now what are definite integrals and what are indefinite integrals. But the summary of indefinite integrals are the case like what you are working out here. When we're integrating without limits, then those are indefinite integrals. But integration that takes place within a given set of limits, where you have the upper and the lower limits, is called is what we refer to as definite integrals. So when working out these definite integrals, what do we do? So for definite integrals, this simply integration with limits. Integration with limits. What I mean for this case is, for example, if you have a case of integrating x, that's the dx, ab, then a and b are the limits. A and b are limits for which integration is supposed to take place. A is the lower limit, and b is the upper limit. So if we integrate this, then we are going to have x, this power n, so xn plus 1 over n plus 1, then plus a constant c, a to b. So what it means is the value of x is b and the value of x is a. So we substitute in a and b in this the integral values to get the value for c in this case. But we shall see what will happen to c. So let's substitute. When x is b, replace here, we'll have b n plus 1 over n plus 1 plus c. We minus the lower limits, replace in a, so we have a power n plus 1 over n plus 1 plus a constant c. Hope we're together. Now what we do is we expand this, so we shall have b power n plus 1 over n plus 1 plus c. Then when we substitute the negative into this bracket, we'll have negative a power n plus 1 over n plus 1, then minus c. Minus the value for c. So let's work it. Let's work it out. The negative c and the positive c will cancel out. So c and c, this cancel out because this plus c, negative c will cancel out. So we'll be left with b power n plus 1 over n plus 1, then plus, that is minus a power n plus 1 over n plus 1. So in this case then, you will see the denominator is a common term. It's a common term which is n plus 1. So we'll factor out. We'll factor out, that is 1 over n plus 1. So this will give us 1 over n plus 1 into, now b plus n plus 1 minus a n plus 1. And that is the way we will carry out definite integrals. When you're given the limits, first of all, what will happen is that the constant will cancel out. So we'll only be left with this part where we'll now substitute in the upper limit, get the solution, again substitute in the lower limit, get the solution, and get the difference to obtain your definite integral value. So in this case then, what do we mean by definite integral? If you are told to evaluate, we have this is 1 and 3, x squared plus 1. We are told to integrate, that is x squared plus 1 dx. It means from 1 to 3. So what do? We start with this function. We have x squared plus 1. 1 to 3 will be x 3. Why 3? Because we are saying we add 1 to the power. 2 plus 1 is 3. We divide by the new power, which is 3. Then plus, at this point, we have a constant, 1. And 1 is x power 0. Now it will obtain now power 1. So we have plus x, then plus a constant c. We are integrating this one from 1 to 3. We're integrating that from 1 to 3. So we'll substitute in x equal to 3, and then we subtract when x is equals to 1. This will happen 3 power 3 over 3 plus 3 plus c. Then we minus, when it is 1, we have 1 over 3 plus 1 plus c. Because 1 cubed is 1. 3 cubed is 27. When divided by 3, that is 9. So we'll have 9 plus 3, which is 12, plus c, minus 1 over 3 plus 1, that should be 1 and a third. 1 and a third, then plus a c. Minus, that is minus c. So the negative and the positive dots will cancel. So our solution will be now 12 minus 4 over 3. 12 minus 4 over 3. So this will give us, this is 12 over 1. That will give us 36 minus 4, which is 32 over 3. And that is 10 and 2 over 3. So our solution becomes 10 and 2 over 3. This is what we call definite integrals. We have the limits, and the limits in this case is 1 and 3. Meaning we're integrating from x is 1 to x is equals to 3. If we can take a second example of the same. We can have this case again. Evaluate, that is a 2x3 plus x squared minus 5x, the x, that is from 0 to 2, from 0 to 2. It implies that this is our lower limit, this is our lower limit, and this is the upper limit. So first thing, let's integrate the polynomial. We'll have 2x cubed, so we have 2x. Now 3 plus 1 to have 4. We divide by the new power 4 plus x. Now 2 plus 1, that is 3, over the new power 3, minus, this is 5x power 1. Now we add 1, have 5x power 2 over 2. Then we add a constant c, and we are integrating this from 0 to 2. Integrating that from 0 to 2. If you simplify this, this is a half, because 2 over 4 will give us a half x power 4. So this is a half x power 4. We replace in the value of x equal to 2. Then we subtract when x is 0. So let's start with 2. We shall have 2 power 4 over 2 plus 2 power 3 over 3 minus 5 into 2 power 2 over 2 plus c. Then we subtract when x is 0. We have everything here is 0. Then in the bracket we have c. So this will happen. 2 power 4, that is 16, over 2 gives us 8, plus 2 power 3, that is 8 over 3, 8 over 3, then minus, this is 4, divided by 2, that is 2 times 5, 10, plus c, then minus c, and you will see the c will cancel out. So we are left with, this is the 8 over 3 minus 2. If you work out this, the LCM should be 3, and so this is 8 minus 6, which is 2 over 3, and that is the value for our question 2. So after you've worked out with the upper limits, substitute in the value of x with the lower limits to get your solution. Lastly, on the same, you can have this case. You are told to evaluate 3x, we have 3x cubed minus 2x squared plus x, that is the x 0 to 3. So far, we've done 2 examples, so you should be able to try this. You should be able to try this on your own. But let's see what we will do. We start by integration. We add 1 to the power. So we have power 3 at this point. Now we have, we'll obtain 3x power 4 over 4 minus 2x. This is power 2. We add 1 to have power 3 over 3. Then plus x at this point is power 1, so we'll have x power 2 over 2, then plus a c. And we are doing the integration from 0 to 3. We replace in when x is 3. So we shall have 3 into 3 power 4 over 4 minus 2 into 3 power 3 over 3 plus 3 squared over 2, then plus c minus, now when it's 0, everything here will be 0. Up to this point we have now only c. So 3 power 4 that is 81. 81 times 3, 243. So 243 over 4 minus 3 power 3, that is 9. 27 times 2, 54 over 3. You add 3 squared, that is 9 over 2. Then plus C, then minus C. And you see the negative C and the positive C will cancel out. So we have now 243 over 4 minus 54 over 3 plus 9 over 2. And the LCM for these numbers, that will be 12. So we have 343 times 12, that will be 9. 12, 729, then minus 4 times 54, that will give us 216, plus 6 times 9, that is 54, then over 12. So that will be our solution. So we work out 729 minus 216, that is 3, and that is 1, that is 513. 513 plus 54, that is 567 over 12. And so this one should be able to give us 12 into 54, 56, that is 4, because of 48. We are left with 8 into 87, that is 12, 7. 12 by 7, that is 4. We are left with 3 over 12. So that is 47 and 1 over 4. 47 and 1 over 4. So that is the solution for the integral value of 3x cubed minus 2x squared plus x from 0 to 3. From 0 to 3. So that is our second part when you're looking at definite and indefinite integral. In indefinite integral, there are no limits given, and that is the case where you're just told evaluate, then you're told that is about to integrate, then there is no limit given. But for indefinite integral, we give you the limits for which you're supposed to integrate your function. Number 3, we need also to review something on area under the curve. Area under the curve. And this topic, integration, is covered after the topic called area approximation, where we look at area approximation using two methods. We approximate in area approximation, we use methods. Method 1, that is the counting method. In the counting method, it is the area of irregular shapes. If you are looking at the area of irregular shapes, that we'll use the counting method, where we divide the shape into squares, then we count the number of complete squares and number of incomplete squares, we divide by 2, we add them together to obtain the area that particular shape has. That method is covered in Form 1. And so we have method 2, which is covered in that topic, is method 2, that is the mid-ordinate rule. Mid-ordinate rule. And then we cover method 3. Method 3, what we call the trapezoidal rule. Those are the 3 methods that are covered in area approximation. And so after we've looked at this in topic 9, topic 10, now we look at integration, which is area under the curve. Now you'll find that these methods, these 3 methods, are mere approximations. These are simply approximations. They don't give you the exact area under the curve. But when you're working out area using integration, we obtain the exact area. So area here will be the exact or the actual area that is covered by that particular curve. So in other words, if you're told to calculate area under the curve, that's the exact area under the curve, then the process you're going to apply is integration. And which integration are we going to apply here? We're going to apply what we call definite integrals, because definitely we shall have the limits within which we are supposed to integrate to obtain the area under under the curve. So let's look at how do we work out area under the curve, like in this case. So we have area under the curve, This one is using integration, So let's do it practically. If you are told to evaluate the area enclosed by the curve, y is equals to x squared minus 4, and the x-axis, In this case, x is equals to -2 and x is equals to 2. If you have this case, the curve is y is equals to x squared minus 4, definitely tells you that this is a quadratic curve. So it cuts the x-axis at 2 points. And we want to see, by sketching, how do we sketch this curve on our Cartesian plane. And the principle for sketching is based on your understanding of where the curve cuts the x and the y-axis. That's the simplest way to sketch any curve. So this curve, it cuts the x-axis. At the point y is equals to 0. So if y is equals to 0, we substitute it here. It means, therefore, x squared minus 4 is 0. So we take a minus 4 to the right side. So x squared will be equal to positive 4. And so x is plus or minus 2, because the square root of 4 can either be a positive value or a negative value. Then on the y-axis, x is equals to 0. Now replace it here, x is equals to 0. It means y will be equal to -4. So it means this curve, it casts the y-axis below the x-axis. So this could be -1, -2, -3, and -4. These are y-axis, 1 and 2. Then on the x-axis we have -1, -2, -3, 1, 2, 3. This is being our x-axis. So if we sketch, it means the curve cuts the x-axis at these 2 points and at the y-axis at this point. So this is the curve. If we sketch, that is our curve. So it means the region that we are calculating the area is enclosed by the x-axis and the curve. And this region is below the x-axis. This is the region that we are supposed to calculate its area, the one that we've shaded. And so when you're calculating by integration, then we say area will be equal to, we integrate the function of the curve, which is x squared minus 4 with respect to dx from x is -2 to x is 2. So we work out this and say x squared now shall have x cubed. Why? Because we are adding 1 to the power. We divide by the new power, minus 4 x, then we add c from -2 to 2. -2 to 2. So we substitute in x is equals to 2, and then x is equals to -2, then we get the difference. So if we substitute in, we have 2 power 3 over 3 minus 4 into 3. We add c, then we minus, when it is -2, we have -2 cubed over 3 minus 4 into negative 3, negative 2, then we add c. So this will give us 8 over 3 minus 12 plus c minus, at this point we shall have negative 8 over 3. Now when we substitute in the negative, negative, now we obtain plus 8 over 3. Then plus, at this point we have 4 times negative 2, so we shall have negative 8. Negative 8 plus c plus negative 2. This should be 2. So we have 2 times 4, that is 8, plus c, then plus 8 over 3 minus 8 plus c. This is negative, so that now we have negative and the positive cancel out. Then we have 8 over 3 plus 8 over 3, that is 16 over, this is plus, thank you, that's plus, that is 16 over 3 plus, this cancel out, so we have plus 0. So the solution becomes now, that is 5 and 1 over 3 square units. Because we are looking at the area, so it becomes 16 over 3. So we have 2, let's see, this is negative 8 over 3 minus 4, that is plus, this is negative 8. This is negative 8, because what we have here is negative 4 times negative 2 is positive 8, then we substitute in the negative, this becomes negative 8, then this is negative c, yes. This is now what we have. So again, this is negative 8. So use your calculator as well. You'll have this is negative 16 over 1. And so this is the LCM is 3. Then we have 16 minus, at this point this is 3. That is 48. So the answer is negative 32 over 3, which is negative 10 and 2 over 3 square units. But then area cannot be negative. So what this negative implies, the negative implies that the area is under the x-axis. And so we take the absolute value for the area, which will be now be positive 2 over 3 square units. So that is the area under the curve. The area under the curve is. Now, we can also have another case. Let's look at this one as our question 2. We find the area under the curve, y is equals to x cubed. Y is equals to x cubed. X-axis, and the lines x is equals to 2, and the lines x is equals to minus 2, and x is equals to positive 2. It is important that you sketch, because when you sketch, you'll be able to tell which is the part that you're calculating the area for, whether it is below or above the x-axis. So in this case now, we'll sketch our curve. X cubed. The fact that the curve has the function is y is equals to x cubed, it tells you that this curve cuts the x-axis 3 times. But let's see, between the region x is negative 2 and x is 2. Now, when x is 0, y should be 0. So at this point, when x is 0, y is 0. It means on the y-axis, it means that is the point where the curve will cut the y-axis, the x-axis, when x is 0. y will be 0. Again, if y is 0, x will definitely be 0. Then when x is negative 2, as it is given here, then we shall have y will be equal to negative 2 cubed. So that is negative 8. And when x is equal to 2, y will be equal to 2 cubed, which will be 8. So we have positive 8 and negative 8. So if we sketch, this is what we shall have. This is the x-axis, the y-axis, 0, negative 1, negative 2, 1, 2. This is 1, 2, 3. Let's say this is where we have our 8, 2, 4, 6, 8. Then on this side again, 1, 2, 3, 4. Negative 2, negative 4, negative 6, negative 8. So we'll have the curve at this point 0, 0. Then negative 2, negative 8 at this point, and then 2 and 8. So our curve will be that way. So we are looking at the area bounded by the curve, the x-axis, that is the area that we are looking for. So we have two regions. We have region 1, this is our region 1, and our region 2. The first region is below the x-axis, and our second region is above the x-axis. So one of the area will be negative, the other one will be positive. But then we are saying we are taking the absolute value for the area, which is the positive value. So let's work it out. Now in this case, we are going to carry out two different definite integral where we integrate twice. In the first integral, we are integrating from x is negative 2 to x is 0. Then the second part, we integrate from 0 to 2. So those are two different limits that we are working with. So we'll find region 1, that is area 1. Area 1 will be, we integrate the function, which is x cubed, from negative 2, which is the lower limit, to 0, which is the upper limit. This will give us x power 4 over 4 plus 1, then negative 2 to 0. This is plus c. So we'll have, replace 0, everything here will be 0. When we replace negative 2, we'll have our solution is negative 2 power 4 over 4. So it is now 0 minus 0 minus this. This is 16 over 4, which is 4, and the answer is negative 4. But we are saying we don't have negative area, so our area 1 becomes positive 4 square units. Positive 4 square units. Go to area 2. Area 2 now is the region enclosed from x is 0 to x is 2. We integrate again, integrate from, that is x cubed, dx from 0 to 2. This will give us, when you integrate this, you have x power 4 over 4 plus c, again from 0 to 2. So now we replace in 2, we'll have 16 over 4, which is 4, then minus 0. So in equal 4x, 4 square units. 4 square units. Therefore, the total area is 4 plus 4, which is 8 square units. We shall have obtained our area, which is 8 square units. So students, that is what we do in our third part, the area under the curve. We look at the area by what we call integration. Look at area by integration. So if you're asked to determine exact area of a curve, then know that we are going to apply the process of integration, and that is an example that we've worked out here. Then finally, it is important also to understand in this topic, we have what we call application of integration to kinematics, where we deal with the displacement, velocity, and acceleration. So the simplest way to capture this information is to remember two things in differentiation. That when you're dealing with the cases for displacement, velocity, and acceleration, we have at this point displacement, and the displacement function is given in terms of s. Then at this point we have velocity function, and the velocity function given by v. And then finally we have the acceleration function, which will be in terms of a. When you have a displacement time graph, that is in linear motion in form 2, displacement time graph, the gradient of the displacement time graph gives us velocity. So we move in this line. When you have the velocity and the velocity time graph, then we will obtain acceleration. So when you're moving downwards, this is the derivative, so ds dt, because the displacement function is given in terms of s and t with respect to time. This point, dv dt, we differentiate velocity with respect to time. Now when you're moving backwards, given now the acceleration function, to obtain the velocity function, now we do the reverse of differentiation, which is integration. So we integrate velocity, we integrate acceleration function with respect to time. When you have velocity, to get displacement, you move again, you integrate velocity with respect to time. Those are the two things that you need to master. That when you're given displacement function with respect to time, to get velocity, we differentiate. When you're given velocity function with respect to time, to get acceleration, we differentiate. But now when you have acceleration to get velocity, you integrate. When you have velocity to get displacement, again you integrate. So if the question is with acceleration and they're looking for displacement, it means you're going to carry out you are going to integrate twice. The first time to get velocity and the second time to get displacement. That is what we need to know when it comes to application. Because most of the time questions will be combining both acceleration, differentiation and integration, and it will be very important if you understood the procedure. Let's take one example of this case. An example of what we do. The velocity v meters per second of a particle moving from a fixed point O is v is equals to 2t squared plus 3t minus 4 plus 3t minus 4. Then you're told to find the displacement of the particle, at t is equals to 2 seconds. We find the displacement of the particle at t is 2 seconds. So we have the velocity function. So to get the displacement s, we integrate the velocity function with respect to t. So we'll have our v, which is now 2t squared, so we'll have 2t cubed over 3 plus 3t squared over 2 minus 4 plus a c. That's our displacement. So we are looking for the displacement of the particle at t is equals to 2. So in this case, s will be equal to, we replace into 2 cubed over 3 plus 3 into, that is 2 squared over 2 minus 4. Then the c in this case become arbitrary. So we're going to have now 2 cubed, that is 2 cubed, that is 8 times 2, 16 over 3 plus, this is 4, that is 2, 6, then minus 4. So we have 16 over 3 plus 2. That is 40. That is t, that is times 2 times 2. So this gives us 4 minus 8, 6 minus 8, which is negative 2. Negative 2. So when you work out this, the LCM is 3. You have 16 minus 6, which is 10 over 3. And the solution is now 3 and a third. 3 and a third. Okay, let's finish up with the last case. You have now again you can have this case where you have you are told that in this case you are told number two is that the velocity v meters per second of a moving body at time t seconds is given by s is equals to that is v is equals to 5t squared minus 12t plus 7. So calculate the acceleration when t is 2 seconds. Calculate the acceleration when t is 2 seconds. Now, the difference between this and this, in this case, you are given the velocity to get acceleration. So we are saying when you have the velocity function to get acceleration, then you carry out differentiation process. So that will be, we differentiate the velocity function, that is dv dt, and we'll differentiate 2 times 5, that is 10 t minus 12 minus 12. Then at t is equals to 2, a will be 10 into 2 minus 12. So this is 20 minus 12, which is 8 meters per second squared, or 10 meters second squared. So those are the areas that we need to revise on when you're revising on integration. You need to prepare, know how to integrate polynomials, know how to work out definite integrals, know how to work out area under the curve, and in that case you're looking at the exact area, and then lastly know how to work out application to kinematics. And the application to kinematics, be able to know this structure. When you have the displacement function, to get velocity function, differentiate with respect to t. When you have velocity function, to get acceleration function, differentiate to get acceleration. Then when you're moving backward now, when you have acceleration function with respect to time, to get velocity function, you integrate. When you have velocity function with respect to time, to get displacement function, you integrate the velocity function. So those are the areas that I wanted us to look at in our lesson today. So once again, I want to thank you for being part of the lesson and for your contribution towards this lesson. From my side, or my end, and the LIM Live, we wish you a nice day. And as always, we always tell you to keep practicing this subject even as you stay at home. Thank you so much, and meet you next time.